This is a video from the Chapter 6 review. We're looking at problem 16. A 1,600-pound elevator is suspended by a 200-foot cable that weighs 10 pounds per foot. How much work is required to raise the elevator from the basement to the third floor, which is a distance of 30 feet? Let W1 be the work required to raise the elevator. And so W1 is 1,600 pounds times 30 feet, right? We're raising the elevator a distance of 30 feet. And so when we multiply 1,600 times 30, we get 48,000. So W1 is 48,000 foot-pounds. We're going to let W2 be the work required to raise the bottom 170 feet of cable. Okay? So we have a 200-foot cable. Now, if we look at this top piece, that's 30 feet. Because remember, we're raising a distance of 30 feet, right? When we move that 30 feet, we're done. And then we have a bottom 170 feet that's going to go along as, it's going to go along for the ride. So that's going as like a single entity. As that top 30 feet is moving, so is the bottom 170 feet, and we have to account for that. So we're going to let W2 be the work required to raise the bottom 170 feet of cable. So W2 is 170 feet times 10 pounds per foot, that's the weight of the cable, times a distance of 30 feet, right here. And when we're all done, we get 51,000 foot-pounds. So remember, we're trying to find the work required to raise this top 30 feet of cable. But when we raise that top 30 feet of cable a distance of 30 feet, the bottom 170 feet is coming along as well. So that's why we need that W2. Now, when we look at W3, that's the work required to move the top 30 feet of cable. And so W3 is the integral from 0 to 3 of 10x dx. So we're integrating force. X is between 0 and 30, right? So we have x feet times 10 pounds per foot, and we're integrating that with respect to x. So this is 5x squared evaluated from 0 to 30, which is equal to 5 times 30 squared, right? Foot-pounds. And then this is 4,500 foot-pounds. And so the total work is W1 plus W2 plus W3. So we can go to the next page, and we can say that the total work is 48,000 plus 51,000 plus 4,500. And so this is 103,500 foot-pounds. And that's how we do problem number 16. And that'll conclude this video for the Chapter 6 review, problem 16. So again, one thing I want to again emphasize and stress, right, is we have a 200-foot cable on the previous page, and we want to move the top 30 feet of cable. But if you move the top 30 feet of cable, the 170 feet of cable at the bottom has to move along with it. So you can't move the top 30 without moving the bottom 170 feet as well. So I want to make sure that makes a semblance of sense. Okay, thank you.